Okay, so variables. A variable provides us with named storage that our programs can manipulate. Okay, named storage that our programs can manipulate. Each variable in C++ has a type. The type determines the size and layout of the variable's memory. The range of values that can be stored within the memory, within that memory, and the set of operations that can be applied to that variable. C++. Okay. C++ programmers tend to refer to variables as variables or objects interchangeably. Variable definitions. A simple variable definition consists of a type specifier followed by a list of one or more variables separated by commas and ends with a semicolon. Each name in the list has a type defined by the user specifier. A definition may optionally provide an initial value for one of the names it defines. Okay, so sum and value have type int, sum and unit sold have initial value 0. That item type has sales item. String is a library type representing a variable length sequence of characters. Book initialized from string literal. Okay. The definition of book uses std string library type. Like iostream, string is defined in namespace std. We'll have more to say about string in chapter 3. For now, what's useful to know is that a string is a type that represents a variable length of characters. The string library gives us several ways to initialize string objects. One of these is a copy literal. This book is initialized to hold the characters. What is an object? The C++ programmers tend to be cavalier in the use of the term object. Most generally, an object is a region of memory that can contain data and has a type. Some use the term object only to refer to variables or values of class types. Others distinguish between named and unnamed objects, using the term variables to refer to named objects. Still, others distinguish between objects and values, using the term object for data that can be changed by the program and the term value for the data that are read only. In this book, we'll follow the more general uses that an object is a region of memory that has a type. We will freely use the term object regardless of whether the object has a built-in or class type in named or unnamed, is named or unnamed, or can be read or written. Okay, initializers. An object that is initialized gets the specified value at that moment it is created. The value used to initialize the variable can be arbitrarily complicated expressions. When a definition defines two or more variables, the name of each object becomes visible immediately. Thus, it is possible to initialize a variable to the value of one defined earlier in the same definition. Okay. Initialization in C++ is a surprisingly complicated topic and one we will return to again and again. Many programmers are confusing by the use of equal to symbol to initialize a variable. It is tempting to think of initialization as a form of assignment, but the initialization and assignment are different operations in C++. This concept is particularly confusing because in many languages the distinction is irrelevant and can be ignored. Moreover, even in C++, the distinction often doesn't matter. Nonetheless, it is crucial concept. We will read it, right? Okay, list initializations. One of the ways in which initializations is a complicated topic is that the language defines several forms of initializations. For example, we can use any of the following 4 different ways to define an int variable named unisold. Oh, damn, dude. The generalized use of curly braces for initialization was introduced as a part of the new standard. This form of initialization previously had been allowed only in the more restricted ways. For reasons we'll learn in this form of initialization is referred to as list initialization. Okay. Braced lists of initializer can now be used whenever we initialize an object and in cases when we assign a new value to the object. Okay. When we use with variable of built-in types, this form of initialization has one important property. The compiler will not let us Initialize variable of built-in types if the initializer might lead to loss of information. Okay. Error narrowing conversion required. Okay, but value will be truncated. Okay. Narrowing conversion required. Error narrowing conversion required. Okay, so this cannot. Curly braces is list initialization. Okay, and simple brackets parentheses. Okay, so this gives error. The compiler rejects the initialization of A and B because using a long double to initialize an int is likely to lose data. At a minimum, the fractional part of LD will be truncated. In addition, the integer part of LD might be too large to fit into the int. Okay. As presented here, the distinction might seem trivial. After all, we're unlikely to directly initialize an int from a long double. However, as we'll see in chapter 16, such initializations might happen unintentionally. We'll say more about this initialization here. Okay. Default initialization. When we define a variable without an initializer, the variable is default initialized. Such variables are given the default value. What that default value is depends on the type of variable and may also depend on where the variable is defined. Okay. The value of an object of built-in type that is not explicitly initialized depends on where it is defined. Variables defined outside any function are initialized to 0, with one exception we'll cover. Okay. Variables of type built-in type defined inside function are uninitialized. Okay. The value of an uninitialized variable is undefined. It is an error to copy or otherwise try to access the value of variable whose value is undefined. Okay, right. Each class controls how we initialize objects of the class type. In particular, it is up to the class whether we can define objects of that type without an initializer. If we can, the class determines what value the resulting object will have. Most classes let us define objects without explicit initializers. Such classes supply an appropriate default value for us. Okay. String says if we do not supply an initializer, the resulting string is empty. Some classes require that every object be explicitly initialized. The compiler will complain if we try to create an object of such a class with no initializer. Alright. Uninitialized objects of built-in type defined inside a function body have undefined value. Object of class type that we do not explicitly initialize have a value that is defined by the class. Okay. Explain the undefined. Explain the following definitions and for those that are illegal, explain what's wrong and how to correct it. Okay, you cannot list initialize this. This is okay. Double salary equals wage equals. This is also okay. I don't know about this, so we will try and get it. This the okay. This is the test one. You can delete it. Work. Let's go here. I think I should hide. Then we variables in basic here, like exercises. I am on exercise 2.2.1. Exercise 2.2.1. This is Cn. Let's try this. You can just go make. Okay. Okay, so it throws in an error. Expected primary expression before int. So it throws in an error. Throws an error saying expected primary expression before int input value. Okay, so we have what are the initial values. Say outside the function is equivalent of 0, and inside the function is undefined. Okay. Variable declarations and definitions. To allow programs to be written in logical parts, C++ supports what is commonly known as separate compilation. Okay, separate compilation lets us split our program into several files, each of which can be compiled independently. Okay. When we separate a program into multiple files, we need a way to share code across the files. For example, code defined in one file may need to use variable defined in another file. As a concrete example, consider stdcout. stdcout and scene. These objects are defined somewhere in standard library, yet a program can use these objects. Okay. Uninitialized variable cause runtime problems. An uninitialized variable has an indeterminate value. Trying to use the value of an uninitialized variable is an error that is often hard to debug. Moreover, the compiler is not required to detect such errors, although most will warn about at least some uses of uninitialized variable. What happens when we use an uninitialized variable is undefined. Sometimes we're lucky and a program crashes as soon as we access the object. Once we track down the location of the crash, it is usually easy to see the variable was not properly initialized. Other times the program completes but produces erroneous result. Even worse, the result may appear correct on one run of the program but fail on a subsequent run. Moreover, adding code to the program in an unrelated location can cause what we thought was a correct program to start producing incorrect results. We recommend initializing every object of built-in type. It is not always necessary, but it is easier and safe. Yeah. To support separate compilation, C++ distinguishes between declarations and definitions. A declaration makes a name known to the program. A file that wants to use a name defined elsewhere includes a declaration for that name. A definition creates the associated entity. A variable declaration specifies the type and name of a variable. A variable definition is a declaration. In addition to specifying the name and type, a definition allocates storage and may provide variable with an initial value. Yeah. To obtain a declaration that is not also a definition, we add the declare then extern keyword and may not provide an explicit initializer. Any declaration that includes an explicit initializer is a definition. We can provide an initializer on a variable defined as extern, but doing so overrides the extern. An extern that is an initializer is a definition. Okay. It is an error to provide an initializer on an extern inside a function. Variables must be defined exactly once but can be declared many times. The distinction between declaration and a definition may seem obscure at this point, but is actually important. To use a variable in more than one file requires declarations that separate from the variable's definition. To use the same variable in multiple files, we must define that variable in one and only one file. Other files that use the variable must declare but not define that variable. Okay. We'll have more to say about C++. This is a definition, declaration. Separate compilation here. Okay, so let's add text. I'll go with definition. Oh, definition. Then definition. Then we'll go with declaration. Okay. Key concept: static typing. C++ is a statically typed language, which means that types are checked at compile time. The process by which types are checked is referred to as type checking. As we've seen, the type of an object constrains the operation that the object can perform. In C++, the compiler checks whether the operation we write are supported by the type we use. If we try to do things that the type does not support, the compiler generates an error message and does not produce an executable file. As the programs get more complicated, we'll see that static typing can help find bugs. However, a consequence of static typing is that type of every entity we must know be known to the compiler. As one example, we must declare the type of a variable before we can use that variable. Identifiers. Identifiers in C++ can be composed of letters, digits, and underscore characters. The language imposed no limit on name length. Identifiers must begin with either a letter or an underscore. Identifiers are case sensitive. Upper and lowercase letters are distinct. Okay, The language reserves a set of names listed in table 2.3 for its own use. These names may not be used as identifiers. The standard also reserves a set of names for use in standard library. The identifiers we define in our own program may not contain two consecutive underscores. Okay, nor can an identifier begin with an underscore followed immediately by an uppercase letter. In addition, identifier defined outside a function may not begin with an underscore. Okay, that's a lot, man. Conventions for variable names. There are a number of generally accepted conventions for naming variables. Following these conventions can improve readability of program. An identifier should give some indication of its meaning. Variable names normally are lowercase. Like we define classes. We define usually begin with an uppercase letter. Identifiers with multiple words should visually distinguish each word. For example, student loan, student, not student loan. Okay. So these are all the words that are not to be used. Alternative name and okay. Which, if any of these names are invalid. Uh, this is invalid. I'm pretty sure. This is good. This is not good. Yeah. Okay. So let me add text invalid. I actually don't know about this, so I'll say that number. Actually, don't know about that. I would have to check. What exercise is this? 2.2.3. Exercise 2.2.3. Okay. Oh, okay. Alright. I didn't know that. Name underscore. I'm pretty sure that would be invalid. One underscore. Yeah. Rest is okay. The scope of a name. At any particular point in a program, each name that is in use refers to a specific entity, a variable, function, type, and so on. However, a given name can be reused to refer to different entities at different points in the program. A scope is part of the program in which a name has a particular meaning. Most scopes in C++ are defined by curly braces. The same name can refer to different entities in different scopes. Names are visible from the point where they are declared until the end of the scope in which the declaration appears. Okay. Okay, so from this we have a scope here. Okay, and val only has scope here in this. Okay, val is only valid here. This program defines three names: main, sum, val, and uses namespace std along with two names from that namespace, cout and indel. The name main is defined outside any curly braces. The name main, like most names defined outside of function, has global scope. Okay. Once declared, names at the global scope are accessible throughout the program. The name sum is defined within the scope of the block that is the body of main function. It is accessible from its point of declaration throughout the rest of the main function but not outside it. Okay. The variable sum has block scope. It's called block scope. Okay. The name val is defined as the scope of for statement. It can be used in the statement but not elsewhere in the main. Okay. Nested scope. It is usually a good idea to define an object near the point at which the object is first used. Doing so improves Doing so improves readability by making it easy to find the definition of the variable. More importantly, it is often easier to give that variable a useful initial value when the variable is defined close to where it is used first. Right. Nested scopes. Scopes can contain other scopes. The contained or nested scope is referred to as an inner scope. The containing scope is the outer scope. Once a name has been declared in a scope, that name can be used by scopes nested inside that scope. Names declared in the outer scope can also be redefined in inner scope. Oh. Okay, so this is global scope. And we set 0. Okay. And explicitly request the global prints 42. Okay, this is a new object. Right. Okay, so it gives preference to the local object first. Scope resolution operator. Output 1 appears before local definition of reused. Output 1. This is global reused. Yeah. Therefore, this output statement uses the name reused that is defined in the global scope. This statement prints 42 and 0. Output 2 occurs after the local definition of reused. The local reused is now in scope. Thus, this second output statement uses local object named reused rather than global object and prints 0, 0. Output 3 uses the scope operator to override the default scoping rules. The global scope has no name. Hence, the global scope has no name. Hence, when the scope operator has an empty left-hand side, it is requested to fetch the name on the right-hand side from the global scope. Okay. It is almost always a bad idea to define a local variable with the same name as the global variable. 100. I don't even need this. 100 as it is local. Okay, is this program legal? Okay, int I equals 2 and int I equals 0 I, and then we print I. Yes, since I is since I is in the outer scope, and the other I is in the local scope of for function. So when printed by cout, it will use the I with value 100. Yeah. Okay. Compound types. What is the time? Half an hour. Okay. Compound types. A compound type is a type that is defined in terms of another type. C++ has several compound types, two of which references and pointers will cover in this chapter. Okay. Defining variable of compound type is more complicated than the declaration we've shown so far. We said that simple declaration consists of a type followed by a list of variable names. More generally, a declaration is a base type followed by a list of declarators. Okay. Each declarator name a variable and gives the variable a type that is related to the base type. Okay, more generally, a declaration is a base type followed by list of declaratives. Okay, each declarator names a variable and gives the variable a type. The declarations we've seen so far have declarators that are nothing more than variable names. Okay. Yeah. The type of such variable is the base type of the declaration. More complicated declarators specify variables with compound types that are built from the base type. The base type of the type declaration. New standard introduced a new kind of reference or reference for use inside classes. Technically speaking, when we use the term reference, we mean L value reference. Okay, go with that. Okay. A reference defines an alternative name for an object. Okay. A reference type refers to another type. We define a reference type by writing a declarator of the form and D, where D is the name being declared. Ordinarily, refers to is another name of ival. Okay. Ordinarily, when we initialize a variable, the value of the initializer is copied into the object we are creating. When we define a reference, instead of copying the initializer value, we bind the reference to its initializer. Once initialized, a reference remains bound to its initial object. There is no way to rebind a reference to refer to different object. Because there is no way to rebind a reference, references must be initialized. A reference is not an object. Instead, a reference is just another name for an already existing object. After a reference has been defined, all operations reference. Okay. After a reference has been defined, all operations on that reference are actually operations on the object to which the reference is bound. If value 2 assigns 2 to the value ival, same as okay. When we assign to a reference, we are assigning to the object to which the reference is bound. When we fetch the value of reference, we are really fetching the value of the object to which the reference is bound. Similarly, when we use a reference as an initializer, we are really using the object to which the reference is bound. Okay, it's bound to the object. This is bound to the object to which reference is bound. Okay, reference 3 initializes I from the value. Right. Because references are not object, we may not define a reference. So this is not valid. Because we may not define a reference to a reference. But you said this works, right? So okay, ref right int and ref3 equals ref. Is this valid? C++. Okay, this is valid. And if I want to Count F3 will print 125, right? Yeah. Okay. Means F3 sorry. F3 F2. Okay. We can define multiple references in a single definition. Each identifier that is a reference must be declared by the AND symbol. Okay. R I3. I3 is an int. Ri is a reference bound to. Okay. R references. With two exceptions that will govern in 2.4. The type of a reference and the object to which the reference refers must match exactly. Moreover, for reason a reference may be bound only to an object, not to a literal or or to the result of a merge in the expression. Okay. SPF type and which of the following definitions if are invalid? Okay, this is good, this is good, this is not good. Invalid cannot be binded to a literal empty references are not allowed. Okay, I think if we go and F2 then it should throw an error, right? Yeah. Okay. Great. So this is invalid. Which, if any of the following assignments are invalid? I, R, okay, double D and R2 valid. R2 equals, yeah, right. R equals R2, yeah, okay. R2 equals R1. Invalid cannot invalid reference refer to other different type. R1 equals C. Yeah, it's okay. What does the following code print? I equals 5, I equals 10. 10, 10. Both 10. Pointers, okay. A pointer is a compound type that points to another type. Like references, pointers are used for indirect access to objects. Unlike a reference, a pointer is an object in its own right. Pointers can be assigned and copied. A single pointer can point to several objects over its lifetime. Unlike a reference, a pointer need not be initialized at the time it is defined. Like other built-in types, pointer defined at block scope has undefined value if not initialized. Okay. Pointers are often hard to understand. Debugging problems due to pointer error is bedeviled even experienced programmers. Okay. When we define a type by writing a declarator of the form -d, where d is the name of the name being defined, the dash must be repeated for each pointer variable. Okay. So int pointers, both I1 and I2 pointers to int. T2 is the pointer to double, taking the address of an object. A pointer holds the address of another object. We get the address of an object by using the address of operator. Ampersand. P holds the address of item. P is the pointer to item. The second statement defines P as a pointer to int and initializes P to the point int object to the point. Again, because references are not objects and they don't have addresses. Right. Hence, we may not define a pointer to a reference. Reference is not an object. With two exceptions, which we cover: the types of the pointer and the object to which it points must match. PD defining it as and the types must match because the pointer is used to infer the type of object to which the pointer points. If a pointer addressed an object of another type, operations performed on the underlying object would fail. The pointer value, the value that is the address stored in a pointer, can be either in one of the four states. It can point an object, it can point to the location just immediately past the end of the object. It can be a null pointer indicating it is not bound to any object. It can be invalid. Values other than the preceding three are invalid. Okay. Dereference operator. It is an error to copy or otherwise try to access the value of an invalid pointer, as when we use an uninitialized. It is an error to copy or otherwise try to access the value of an invalid pointer, as when we use an uninitialized variable. This error is one that the compiler is unlikely to detect. It is an error to copy or otherwise try to access the value of an invalid, as when we use an uninitialized variable. This error is one that the compiler is unlikely to detect. The result of accessing an invalid pointer is undefined. Give a pointer is valid. Again, although pointers in cases 2 and 3 are valid, there are limits on what we can do with such pointers, because these pointers do not point to any object. Where? What case? Okay. Object. Okay, these cases. We may not use them to access the supposed object to which the pointer points. If we do an attempt to access an object through such pointers, the behavior is undefined. Okay. We take a pointer to access an object. When a pointer points to an object, we can use the dereference operator to access that object. Okay. So P holds the address of I1, P is the pointer to I1, yields the object to which P points, prints 42 mode. Dereferencing a pointer yields the object to which the pointer points. We can assign to that object by assigning the result of the dereference. Right. We may dereference only a valid pointer that points to an object. Some symbols have multiple meanings. Right. Some symbols such as are used as both an operator in an expression and a part of declaration, and as part of declaration. The context in which a symbol is used is determines what the symbol means. Okay, and follows a type and is part of is a reference pointer, address of I. Next question. Yeah, reference is part of the declaration. Okay, so this is a reference to I. In declarations are used to form compound types. In expression, these same symbols are used to denote an operator. Because the same symbol is used with very different meanings, it can be helpful to ignore appearances and think of them as if they were different symbols. Okay. Null pointer. A null pointer does not point to any object. Code can check whether a pointer is null before attempting to use it. There are several ways to obtain a null pointer. Equivalent to 0 constant must include CST. Okay. The most direct approach is to initialize the pointer using the literal nullpedia, which was introduced by the new standard. Nullpedia is a literal that has a special type that can be converted to any other pointer type. Alternatively, we can use literal 0. Older programs sometimes use preprocessor variable named null defined as 0. Yeah. We'll describe the preprocessor in a bit more detail in 2.63. What's useful to know now is that the preprocessor is a program that runs before the compiler. Preprocessor variables are managed by the preprocessor and are not part of the std namespace. As a result, we refer to directly without the. When we use a preprocessor variable, the preprocessor automatically replaces the variable by its value. Hence, initializing a pointer to null is equivalent to initializing it to 0. Modern C++ programmers generally should avoid using null and use It is illegal to assign an int variable to a pointer even if its variable happen to be 0. Okay. As with any other uninitialized variable, what happens when we use an uninitialized pointer is undefined. Using an uninitialized pointer 47. Okay. Using an uninitialized pointer always results in a runtime crash. However, debugging the results crashes can be surprisingly hard. Under most compilers, when we use an uninitialized pointer, the bits in the memory in which the pointer resides are used as an address. Using an uninitialized pointer is a request to access a supposed object at that supposed location. There is no way to distinguish a valid address from an invalid one formed from the bits that happen to be in memory in which the pointer was allocated. Our recommendation to initialize all variables is particularly important. Important for pointers. If possible, define a pointer only after the object to which it should point it has been defined. If there is no object to point to a pointer, then initialize the pointer to nullpedia. Okay, yeah. Okay. Assignment and pointers. Both pointers and references give indirect access to other objects. However, there are important differences in how they do so. The most important is that a reference is not an object. Once we have defined a reference, there is no way to make that reference refer to a different object. When we use a reference, we always get the object to which the reference was initially bound. Again, there is no such identity between a pointer and the address that it holds. As with any other non-reference variable, when we assign to a pointer, we give the pointer itself a new value. Assignment makes the pointer point to a different object. But address is no object. It is the same object I. It's an object. can be hard to keep straight whether an assignment changes the pointer or the object to which the pointer points. The important thing to keep in mind is that assignment changes its left hand operand when we write this. Okay, when we assign a value to pile which changes the address the pile holds. On the other hand, when we write this, then this changed. Other pointer operations. So long as the pointer has a valid value, we can use pointer in a condition, just as we use an arithmetic value in condition. If the pointer is 0, then the condition is false. Okay. Any non-zero pointer evaluates as true. Given two valid pointers of the same type, we can compare them using equality and equality operators. The result of these operators has type pool. Two pointers are equal if they hold the same address and unequal otherwise. Okay. Two pointers hold the same address, that is equal if they are both null. If they address the same object, or if they are both pointers, one past the same object. Note that it is possible for a pointer to an object and a pointer one past the end of the different object to hold the same address. Such pointers will compare equal. Because these operations use the value of the pointer, a pointer used in condition or in a comparison must be a valid pointer. Using an invalid pointer as a condition or in comparison is undefined. We'll go with the additional point operation. Void pointers. The type void is a special pointer that can hold the address of any object. Like any other pointer, void pointer holds an address, but the type of the object at that address is unknown. Pointer to any object. PD. There are only a limited number of things we can do with a void pointer. We can compare it to another pointer, we can pass it to or return it from a function, and we can assign it to another void pointer. We cannot use a void pointer to operate on object it addresses. We don't know the text type, and the type determines what operation can be performed on the object. Generally, we use void pointer to deal with memory as memory, rather than using the pointer to access the object stored in that memory. We'll cover using void pointers in this way here. We'll show how we can retrieve address stored or should I highlight it like this? Write code to change the value of a pointer. Write code to change the value to which the pointer points. I can do that. Key differences: pointers are objects, they are not. They are bound to a single object, they are not bound, but they are bound to a single type. Okay, what does the following? Okay, let me just text. Okay, pointers are objects pointers are objects references are not. Two, pointers can point to multiple variables of same type. References are bound references are bound to the object they refer. They can be declared. They must be defined. Pointers can point to other pointers. References refer to other references. What does the following program do? Can I yeah, there we go. Okay. We take the pointer, then we say the value of calculates the square. Explain each of the following conditions. Indicate whether they are legal or illegal. Okay. Illegal. Can't comment. Must be same type. Okay. Assuming P is the point to explain the code. Checks if the is valid. Check the object checked points to valid. Given a point of being, can you determine whether point of PP? Mm, uh, can't really do that. Why is the initialization of P legal but LP illegal? Understanding compound type declaration. Yeah. Okay, so we'll call it a day.